Let's take a look at a problem that involves, again, going with or against a current or the wind in this case, second example of that type. So in this problem, it says Young, Piper, in his Piper Club airplane, flew an average of 125 miles per hour with the wind, 87 miles per hour against the wind. Determine the speed of the plane in still air and the speed of the wind. Okay. So again, we'll start with the question. So determine the speed of the airplane in still air and the speed of the wind. So we don't know two things. So let's say A is the speed of the airplane in still air. And let's say W is the speed of the wind. Alright, so we don't know two things. That means we need two equations. So first equation, flew an average of 121 miles per hour with the wind. So with the wind, so when you're flying with the wind, with the current, the two speeds add together. So A plus W is equal to 121. Against the wind, against the current, like we saw in the previous example, the two speeds subtract. Just make sure that the object is first. So those are your two equations. Now you can solve this system either using the addition method or the substitution method. Seems like this is perfectly set up for addition. All the variables on one side, and one is positive and one is negative, and all we have to do is add and everything cancels out. So 2 times A is equal to 80208, if I did the math right. And then we can find A by dividing both sides by 2, and we get A equals 104. So if you connect this back to up here, what we just found is the speed of the airplane in still air. We're not done with this. We're going to find the speed of the wind as well. So take either one of the two equations, use 104, and find the other letter. So we have A plus W equals 121. A is 104 plus W equals 121. So minus 104 from both sides. And we get W equals 121 minus 104, which is 17. Alright, so report your answers now. So speed of the airplane in still air is 104 miles per hour, and the speed of the wind is 17 miles per hour. I don't know how many of you have actually experienced this. If you fly from New York, Rochester, Buffalo towards the West Coast, California, for example, when you go towards California, you always take a little bit longer versus coming from California. Now, the distances are the same, but the difference, why one way takes longer and the other way takes shorter time, is because of the wind. When you fly towards California, typically you're flying against the wind. The wind is pushing you back, versus when you fly from California, the wind pushes you along, so you get a speed boost. So this is something you can actually experience when you fly towards California or back from California. All right, that's it for this video. We'll take a look at other two variable problems coming up.